Welcome to the project demonstration of automatic load sharing of transformers supplying DC load and power factor correction by using FACTS device using Arduino. So here we have the two operations which was done by the Arduino Uno board. One is the transformer load sharing, and the transformer load sharing is nothing but here we are using the two transformers. So in that two transformers, one is a main transformer which is act as a PT also, potential transformer for power factor correction, and another is a secondary transformer which will be added in parallel with the primary transformer when the load was increased. So we are using DC loads here, and though we are using DC loads, but the current was measured by using this current transformer before converting the AC to DC. So here see, we can connect in the transformers. Two are in parallel through the this secondary transformer is through this relay connected in parallel with the primary transformer, and the output is AC that was given as input to this regulated power supply board through the CT. So the CT was connected in series, and the output of this regulated power supply board is DC, and that is the DC input to this DC load 1 and DC load 2. The DC load 2 will on with the help of this switch, and when we on this one, the same current will be represented through this current transformer, and that is the input to the Uno board through this potential divider circuit. And the potential divider circuit, we have already checked the voltage when the load 1 is connected and when the load 2 was connected. So based on the comparison, the system will on the secondary load when the load 2 got switched on, as it is considering as a high load, and the secondary the transformer will be connected in parallel with the primary load with the help of this relay, because the neutral connected directly, and the phase was connected through this relay to the primary of the primary transformer directly. So here we have connected the A1 pin for this voltage sensor of this current transformer output. So here the voltage sensor voltage divider purpose is to convert the AC to pure DC voltage. So that is input to the A1 pin of our microcontroller. And the next coming to the power factor correction. So the PT was connected here, and the CT for the AC load was connected, which was in series with the resistive load, inductive load and capacitive load. The capacitive load was parallelly connected for the R plus L. R plus L are R and L are in series, and the switch was to isolate this inductor. So when we on the switch, it will be isolated. When we off the switch, it will be connected in series with the resistive load. Right. So as we know that when we apply the resistive load, so the power factor is unity, as a phase difference between the voltage waveform and current waveform is 0. So that will be retrieved from this potential transformer and current transformer. The current transformer output is and potential transformer output is given as input to this comparator circuit. From there we are going to get the 0 and 1. So when there is no signal 0, when the current wave AC wave starts, it will provide the 1 signal. So the Arduino Uno will compare the time difference between the 0 of 1 of voltage transformer and 1 of current transformer. When the difference is nearby 0, it's a cos 0 is equal to the unity power factor 1. And the next, when the it is increasing the time, then the cos theta value will be increases from 0 to 90, and then automatically the power factor valuation comes down to 1 to the 0.9, 0.7, 0.8 based on the loads which we are using in our project. So here the relay was connected at the pin number 11, and this one is for the pin number 12 and pin number 2 to 7 for this LCD screen, and this one is a breadboard to distribute the 5 volts power supply which we are providing from this adapter, and from there we are distributing the 5 volts power supply throughout the input and output modules. So let us see the demonstration. So first of all, on this load power supply 230 volts, and is a inductive was connected in series with the load, and inductor was disconnected, and then on the power supply to the system. Then there will see a welcome message on the LCD screen, and everything was normal. So coming to the transformer load sharing feature. So when we on this, so you can see the load was high, and this particular relay got switched on, connected a secondary transformer in parallel with primary transformer. So when we off this, again we need to reset the system, come back to the normal condition. It won't do the in auto reset. Right. Okay, and coming to the power factor correction, just on this, so you can see power factor lagging, automatically this relay got switched on. Okay, and when we off this, when we isolate that, now the R plus L will be there, so leading will be done, and automatically this relay will get switched off. So if is there any hanging was occurred, like no message display on LCD screen, or if is any special characters displayed, just reset the system, as we are implementing the like fast operations with one Arduino Uno board. So now everything is normal now. Okay, right. So we are using the here the coming to the potential transformers of checking purpose, and primary transformer ratings are 12 volt, 1 amp. AC output by providing the 230 volts AC input, and CT can measure up to 1 amp. So we are using the CT of 1 amp, which is step up the input voltage to output voltage. Sorry, this one CT1 and CT2, both are same ratings of 1 amp output directly. And here we are using the 100 watts bulb resistive load and 60 watts of inductive load, and 2.2 microfarad for this capacitive load we are using.